Okay, I'm going ahead and recording this activity for my AusPrep kiddos who were not there on Thursday when we covered different sampling methods when trying to gauge the enjoyment level for fans at a Justin Timberlake concert. And my good news is I had a great time camping at McKinney Falls State Park, and there I am with my sister-in-law. We're just kind of taking a dip there at McKinney Falls, having a great time. Open assignments. Don't forget, we have 1, 4, 1, 2, 1, 3, really 1, 2, 1, 3, 1, 4. And those have been extended through Monday at 9 a.m. because I know some of you had trouble logging in. Okay, so in this activity, I got it from statsmedic.com. We're going to look at a Justin Timberlake concert, and the promoter wants to know how much fans enjoy it. They're rating it on a scale of 1 to 100, and he wants to survey a section that has 50 seats in it. He's not going to do everybody. That would be a census. He's just going to take a sample and gauge it. All right, so he wants a sample of 10 seats. So how would we do this? Well, one of the things that would help is to go ahead and number these, right, from 1 to 50. So there you go. There it is, labeled from 1 to 50. And then I'm going to randomize using either a random number generator or table to generate random numbers from 1 to 50. Ignore repeats. Now, if you're using the table, remember a table is 2 digits. So you would actually have to ignore also 00 and 51 to 99. By the way, a table's not always 2 digits, but in this case, we'd use 2 digits because 50 is 2 digits, all right? But we're going to go ahead and use a random number generator. So we're going to stop when we get 10 unique numbers for the fans to be surveyed. Now, I actually am pulling more than 10 numbers because there's a chance I have repeats. Okay, so here are my 20 random numbers I pulled. I'm going to use the first 10 unique numbers. So we got fan 11 right there, fan 7, fan 48, fan 50, fan 41, fan 21. Uh-oh, we already did 50, so we better cross that one out. Fan 29, fan 36, fan 32. That gives me 9. I need one more, fan 25. All right, so again, you've already learned how to take simple random samples in the previous lesson, but just a quick review. All right. For method 2, we're going to go ahead and look at a method called stratification and stratified by row. So what that means is we want representation from every row. So we're going to label the fans in each row from 1 to 10, okay? Then I'm going to use a random number generator to generate random numbers from 1 to 10. I'm going to select 2 unique numbers, ignore repeats, because I could generate a 5 and a 5 since I'm picking 2. And so I need to ignore the repeats there. Then I'm going to take 2 numbers and select the fans in that row, all right? Repeat for each row, it's like 5 separate samples. So here are the random numbers I generated, and I'll explain why there's a 3 there in a second. So for row 1, I'm going to take fan 5. Yeah, it would have helped if I put 1, 2, 3, 4, 5 on the rows there. Then I'm going to take fan 7, then fan 2, fan 7, then fan 2. Fan 5, wait, I've already got fan 5, skip, fan 3. That's why I had 3 there. Fan 6, and then fan 4. All right, so there is my sample. I have 2 people from each row. All right, you can also do it by column. Now I'm going to label them 1 through 5 because I only have 5 individuals in each column, and I'm going to randomize using a random number generator. This time only going to 5 because that's how high I go. And we're only getting 1 fan from each column, so there won't be any repeats, all right? And repeat for each column, it's like 10 separate samples. So here are my random numbers, and I got 5 for the first column, 1 for the second one, 1 for the third one, 3 for the fourth, then 3, then 5, 3, 1, and 3. Okay? I've already talked you through how to get a simple random sample by hand. Luckily, I have this nice simulation so we can see what a lot of simple random samples for Justin Timberlake looks like. And I'm going to just go ahead and generate a sample, right? So how does a simple random sample work? Basically, it can be, notice how we don't have anyone in this row picked, and we don't have anyone in this column picked. It's just randomly, they're using a random number generator. In this case, they said 1, 2, 3, 4, 5, 6. So 6 was one of the numbers generated. And then 7, 8, 9 was also one of the numbers generated. We got 10, 20, 1, 2, 3, 4, 24 was generated, and so forth. So they just created 10 random numbers from 1 to 50, and that's a sample. Now I'm going to scroll down really quickly just so we can start collecting data. All right, oh, it's going to make me generate another sample. So let me generate a sample for stratified by row just very quickly. So here, just as a quick overview, when we stratify by row, what we're doing is we're picking a sample from each row. In this case, we're taking 2 fans from each row. So let me generate a sample here. So you can see I have 2 people in every single row. All right, it doesn't always have to be 2. I could have said 1 from every row, or I could have said 3. In this case, I was going for a total of 10 fans, and I have 5 rows. So that's why we picked 2 from each row, okay? And you can notice that when we stratify by row, we make sure we have representation from every row, okay? We don't necessarily have representation from every column, and that's fine, okay? Now let's go ahead and stratify by column, and I'll generate a sample here. So in this case, sometimes it's harder to notice that you do a column sample. How can you tell? Well, every column is represented here, okay? It's generating a random number from 1 to 5. In this case, for column 1, it generated a 3, then a 4, a 1, a 5, a 1, 3, 1, 3, 5, and 5. Now, does that mean there's representation from every row? No, because we stratified by column, not row. And in fact, you can see that no one in the second row was picked. All right. Now, the other thing you can do is you can do what's called a census. All right, let me kind of scroll this down a little bit just so you can see it better. Ignore that. Whoa, hold on. So in a census, basically what that means is we're going to look at all of the people. So I'll go ahead and reveal the results. So this is their enjoyment rating for every single person. Now that I go back, all right, and I can push this back up again. There we go. I don't really need to see the census. So we can go back and look at multiple samples using each method. So first of all, let's focus on stratifying for a simple random sample. So you can see I got 2, so that's a different one. Again, it's simple random. I don't have anybody in this row or that column. 3, 4, 5, 6, 7, 8, 9, 10. And I can actually go ahead and I'm going to go to the bottom and generate 40 more samples for that. Actually, we'll do 90. We'll go ahead and have 100 samples. So you can probably just barely see that. And if you go up here, here are 100 samples using a simple random sample method, all right? So that on one sample, this dot represents an average of 69 in enjoyment that was achieved on one sample, all right? For the last sample, the last set of data we had, it was 72.8. And you can see that this is pretty much centered about the true mean, all right? So that's pretty much centered about the true mean. And that's the whole point of randomization, is that we remove the bias. All right. So why don't we just do simple random samples all the time? Well, if you have a list of people and they're numbered, it's not a hard way to go. You do have to go say, oh, let me go survey that person and that person and that person. By the way, these numbers are their enjoyment levels, so you can see what they have, right? But there might be a reason to use a different random method. So this is a stratified random sample, right? So I could generate some random samples too here. And what are you noticing? I'm always getting 2 from each row because it says 2 from each row. This is stratified by row because every row is represented. Let's see how many dots do I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to go ahead and add 90 on bottom. Doesn't matter if I have exactly 100. So I'll go ahead and add 90. And you can see the results there. all right? So is this centered about the true mean? It is, okay? So the true mean value, because we did happen to know all of the values, so this is one of the places where we're let behind the curtain to know the true value. It's 78.38. And you can see that we do have some 78.3s, we have some 78.1s, and why aren't they all 78.38? Well, because it's randomization, and sometimes we might just randomly get people like on the edge or the center. So if I click, see like this one, I bet that was a lower value. 76.9, right? Because you don't have as many in the center. Maybe they're slightly better. That's probably a little closer. And so you can see sometimes you're just going to get different values. All right, but what do we notice when we compare these two methods? Well, if you look at the spread on this one, it goes from 69 to 84. 69 to 84. And the spread on this one is from 75.3 to 81.1. So this one's tighter. Both of them are still roughly centered. In fact, I'll go ahead and add a bunch more samples on the bottom to the simple random one. So I'll just add a whole mess of them. I'm going to add 400. Let's see if it'll work. Yeah, it should work. All right, it says max 2,000. So I just added a whole bunch. And you can see the centering, it is pretty darn centered on that, right? And let me go ahead and I'll add a bunch to this one too. I'll just add 400 to the stratified by row. Go. We'll have a bunch of data. And so what you see is just a tighter distribution, okay? So the bias, the common misconception that my students have is that one method is more biased than the other. No, bias means when you are off of the center, where the whole pile is moved. So like if this was like shifted somehow, the centers of both of these piles are roughly the same. So we would say these are unbiased, all right? The difference between them is in spread or variation. And we'll go into that more later, all right? So we definitely, if we want to take a sample and be closer to the true mean, our probabilities are better when we stratify by row. Well, why is that? Well, let's go to the census. I know you can't see, yeah, you can see the whole census. If we look at the top row here, there's very high enjoyment level, right? And if you look at the very back row, it's more in the 60s and 70s. So when you stratify by row, you guarantee you're getting 2 people in the high enjoyment level, 2 people in the lowest enjoyment level, and 2 people from the middle levels, right? From each of these middle levels. So it tends to average out better. Okay. So what do we think is going to happen when we stratify by column? So I'm going to go ahead and generate some more samples. And again, remember, when we stratify by column, that means we're getting representation from each column. Okay, we will have it. And why do we have one person from each column? Well, we're trying to get a sample size of 10, and we have 10 columns. So we pick one from each column. All right, so I'm going to go ahead and pick some more samples. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So, and then we'll start just by adding the 90. We'll just add the 90 data points. So we have 100. But when you get more data points, it really should be there. Come on. I thought I hit it to the stratified by row. That's what happened. That's fine. I need to do a stratified by column. All right. So we'll do 90. There we go. So you can see we've got quite a bit more here, right? And our range is from 69.8 to 85.5. So it seems to be a pretty high range. Let me go ahead and add a bunch of samples. I'm going to add 400 like I did for the other two. And you can see, yeah, it is pretty centered on the true value, but it's got a lot more variation. Why is that? Well, when you stratify by column, you're not guaranteeing representation from the front row. So on this one, this is 79.8. Well, this worked out pretty well because we're kind of in the middle, right? But you didn't have any high values, right? Here, this one probably is pretty good, 78.6, that's pretty close. This one's probably really high. Why is it high? All of our people ended up towards the front. So we would be overestimating the satisfaction that their actual enjoyment, right? Let's go ahead and pick some more. And this one is 77.8. So it's a little bit low because we're a little bit more towards the back here, right? Let's see. Oh, this one's probably high. 84.5. Yeah, it's way over here, somewhere around there. So that is definitely an overestimate because when we do the column, there's no guarantee they're going to be spread evenly from the front to the back. But when we did the rows, we guaranteed 2 in front, 2 in back, 2 in the second row, 2 in the third, 2 in the fourth row. All right. So again, and I'll add a bunch more. I think I did add a bunch more points. So again, the main misconception that my students have is they think that this method, simple random sample, or this one, stratified by column, is more biased than stratified by row. No, they're all unbiased. They're pretty much around the center. But when you take an individual sample, it tends to be tighter on the stratified by row. So there's less spread here because we're getting pretty even representation across the different groups. Now, in stratification, what we're usually looking at is our groups are homogeneous. So this is a good way to stratify by row. Stratifying by column is not so good. All right, here's why. This row, if I go to the census, right, this row is my high enjoyment level. So that's one strata. You can also think of strata like in people, they've used strata like, oh, higher socioeconomic status, right? So you can stratify according to socioeconomic status, how much money people make. And you're going to find more in common with, say, the super rich people and the super poor people. Super rich people have more in common than they do with super poor people, right? So, and then in the middle, it'll be somewhere around there, right? I'm more like the middle. All right. So anyways, same thing for enjoyment for Justin Timberlake, right? Our strata, where are groups that have something in common? All these guys in the front row, they're paying top dollar to go see Justin Timberlake, right? And they're sitting up near the stage, so they're happier. So they have something in common. All these people, apparently they like Justin Timberlake enough to buy a concert ticket, but maybe not enough to pay for the front row. So their enjoyment level is still pretty decent, but it's not as high as the people in the front, okay? So those are the main differences in stratification. So just to recap, again, here are the distributions for the simple random sample, the stratified by row, and stratified by column. And you can see the average for all three is close to the true value. So that means these are unbiased. But the main difference we see is in variation, with the least variation in the stratified by row. And probably it's kind of similar in stratified by column and simple random sample. So you could use any of these methods. You'd just be a bit more precise with this. So speaking of methods, we still have two other methods called cluster sampling and systematic sampling. So how would we cluster sample for Justin Timberlake? Now I kind of numbered these funny. It probably looks like I'm doing stratified by column here. But I'm just saying this is row 1. So if you're in row 1, it's like you're labeled with a 1 and you're in that group. All right, so this is clustered by row. Since we want 10 fans in our sample and each row has 10 fans, we just pick one row. So we'll label our rows from 1 through 5. So if you're in here, you're labeled with a 1. If you're in here, you're labeled with a 2, then a 3, 4, and 5. Use a random number generator to select a random number from 1 through 5. In this case, since I'm only going to draw one row, I don't have to worry about repeats because I'm just doing the first random number I get, all right? And I will select all 10 fans in that row. So here's my random number, it's a 4. So that means I would get this cluster. Everybody in here is labeled with a 4, okay? And do you think clustering by row would be a good choice for Justin to get the satisfaction level, enjoyment level from Justin Timberlake fans? Probably not, because your rows are either going to be like, you're picking one row, so you're either going to be in the front or you're going to be in the back, right? Or in the middle. The middle probably wouldn't be too bad. But these back row, you're going to underestimate. Front row, you're going to overestimate. So we're not even going to look at clustering by row. So let's try clustering by column. So everyone in here is in column 1, column 2, column 3, right? So we're going to want 10 fans, and you can see I only have 5 people in column 1, so I'm going to need to take 2 rows. So I'm labeling the columns 1 through 10. So there are 10 groups to choose from, 10 clusters. I'm going to use a random number table or a generator to select 2 unique random numbers from 1 through 10. Because I'm going to be picking 2, it is possible I'll get repeats. Then I'll select all fans in each of the 2 columns, all right? So here are my random numbers, and sure enough, okay, here's column 6. I'm going to survey everyone in that column. I got a repeat, ignore it, then go get column 2. Okay, column 6 and column 2. So is clustering by row, by column, is that a good choice? I should say column there, for sampling Justin Timberlake fans. And I would say, yeah, the clusters should be similar to each other, and they have representation from the front through the back. So clusters are not about having the same type of people in one group. So you're not grouping people according to their type. Clusters are really more kind of a location thing, and that each location is similar. So column 1 should be kind of similar to column 2, to column 3, column 4. There'll be some variation, and that's fine, but they should be tighter. All right, there's one other method called systematic sampling. So in this case, the applet sets it at every 8th fan. Normally, you can pick it to be every 10th, every 20th, every 50th if you want, right? But we're going to do every 8th. And so that means I'm going to label my fans from 1 to 50. And I'm going to use a random number generator or table to select my starting point. So then I'm going to select that fan and as the starting point, and every 8th fan after that. Wrap around if you need to. So here's my random number. It's a 4. So I'm going to start with fan 4. 8 later is 12, then 20, 28, 36, 44. That's going to be 52. So it wraps around to 2, then 10, 18, 26. And let's see, I think that gives me 10. 1, 2, 3, 4, 6 there. Yeah, that gives me 10 fans. So there is my systematic sample. So what do we think about it? Well, it seems okay. We'll check in the simulation. All right, now part 2 of Justin Timberlake. So you've already seen simple random sample, right? And we're going to keep it here for comparison. And then we're going to do cluster sample. Remember that we're randomly selecting 2 columns. And in this case, you see there the 2 columns we picked, all right? Systematic is every 8th person, like I showed you before. There you go. So let's go ahead and see what happens when we do this a lot, right? So I'm going to go ahead and, does it have the true value? Yeah, well, hopefully it will. All right, so let's go ahead and quickly add, we'll go ahead and do the 1,000. All right, go. And that was to my simple random sample. So there's a distribution, not too different from what we looked at last time, should be very similar. And then we're going to go ahead and look at the cluster sample. Actually, let me generate a couple different cluster samples again. So you can see there they are, different rows. That row was really common for a while. Oh, it's back. So again, and then for systematic, it flips around. It's sometimes hard to tell where the starting point is. We know it's every 8th, but as you saw when I showed you earlier, it will wrap around for sure. And so it's harder to see the pattern on the systematic. So let me go ahead and add 1,000 to the cluster and to the systematic, and we can compare. All right, so looking at these, I definitely see an advantage to the cluster method over the simple random sample method. There's 2 reasons you'd want to go with this. First of all, it is centered about the true mean. Now you'll notice that this seems more finite, right? Like it has jumps in here, whereas this is a little more continuous, right? But here we have the values here and here and here. And if I were to add another 1,000 a cluster, let's do that, add another 1,000. All right. And so it's a little interesting shape there, but it is pretty much centered about the mean, right? The advantage to doing cluster here, and most of my students prefer cluster, is, oh, I just got to go do this column, everybody there, and that column, everybody there. So all you're doing is picking columns. It's super straightforward, and you just do everyone in that column. All right, let's go ahead, and you can see that it is tighter than the simple random sample. Why? Well, we are guaranteed representation from every row, because remember, the rows are different, but the columns are similar, all right? So a row is like a strata, really, all right? Because that means these are the people higher status and lower status, sorry. Whereas a column goes across the strata. You see that? And so this is more of a cluster. Okay. Now systematic, we'll go ahead and generate a few more samples for systematic. Add some more. So there's systematic as well. And you can see it has a little more variation. And it also tends to have jumps on it because there are only certain numbers of sets, which kind of brings me to my point about a simple random sample. In a simple random sample, every combination of people is possible. For example, I can get that 84, that 85, and that 82 in my sample, but I can't do it here. Sure, I could have 84 column and 85 column highlighted, but I can't do the 82 column because, and there's no way I can pick this guy with the 98, but not that guy with the 90. So simple random sample means that every possible combination of 10 fans is possible. That's why it's a little more continuous. Whereas for and actually let me add some more I think it's actually scaling to the tallest one. So let's add another 1,000 up there and maybe a little bit more to get a little bit more height on that. So you can see that this is much more continuous here, right? So there are more possibilities. Whereas here, it does seem to be a little bit clustered on the results, doesn't it? So again, the definition of a simple random sample is that every possible combination for your sample size is possible, all right? Whereas not every possible combination of individuals is possible. Here, you're either getting this group and that group, or you're getting whole groups. You can't leave somebody out, and you can't add somebody in that's not in that group. Systematic sampling also has a similar issue in that it skips every so many, so I can't have this person necessarily and that person. It depends. It depends. But it's trickier to try and get those, and they're not all possible. So odds are you wouldn't have 3 people in a row in a systematic. In fact, if I kept generating new samples, you'll notice there should not ever be 3 people in a row. Where that is possible, not likely, but it's possible. See, I already have 2 in a row. I wonder if I can get 3 in a row. Oh, well, there was 3 in a row right there. All right, just back there, I got 3. Oh, there's another 3 in a row. See, I can get 3 in a row on here. All right. So can't do that with the systematic. Anyways, so, but the advantage of the cluster sample, even though I can't get every possible combination, because the clusters are sort of representative of our group, it's okay. It's fine. Because it's not like we really need to get those 3 people together. But it's basically about getting representation from your sample. So clusters are fine if you can create clusters that kind of scan across all of your values. Like here we have high to low, right? Whereas, so cluster by column here is good. Cluster by row would not be so good, as I mentioned before. Systematic's not too bad either, but there is some variability. I guess compared to a simple random, it's actually a little bit better. It's a little tighter. But cluster is the best looking graph here, even though it is sort of wonky in terms of it's a little tighter. You have a little better shot of getting closer to your mean on an individual sample. So again, just looking at it, you had simple random sample, widest variation. Everything is unbiased and centered about the mean, including the simple random, the clustered, and the systematic. The tightest was clustered by column, and systematic wasn't too bad. So the big ideas in this lesson: sampling methods. There are 3 steps. You want to label, randomize, and select. All right. On simple random sampling, choosing a group from the population. So you want to choose a group from the population so that every individual and group of individuals has an equal chance of being chosen. So that's kind of how you do it. Not saying that's the best method for every situation though, but that is the definition of a simple random sample. Stratified random sampling splits populations into groups or strata, and it's basically they are people that are individuals that have something in common. And then you're like, okay, I have front row people, so I'm going to take a sample of front row, middle section, and back section, right? So you get some from all of the groups, all right? Cluster sampling is the favorite for people because it's like, okay, you just pick a few groups here and there, and you just survey everyone in the group. And it works fine as long as your clusters are representative of your total population. So your clusters should be a little bit similar. They don't have to be the same, but there shouldn't be any reason to think one cluster is different from another cluster. And then finally, we have a systematic random sampling, and that's using randomization to select a starting point and then sample every nth individual. This is great for individuals entering or exiting a location, or if you have people in line for something. Systematic sampling is a much easier method to use. All right, so also randomization eliminates bias, right? That's all of these are unbiased methods, all right? Just some have more variation than others. And the methods may have different levels of variation depending on the situation. There could be a situation where stratified works way better than cluster, all right? So it just depends. I would say for our activity today, stratified had the least variation when we stratified by row. So AusPrep, what now? Make sure you can open the assignments on WebAssign. The class key is cedarridge.tx78509542. And have you signed up for my remind? Make sure you did that. And these are the open assignments. They're all due Monday and accessible at webassign.net.